All right, one of the great mysteries in life, and in this class, is when we talk about matter, is to know where it all came from. Now, there's lots of ideas of where matter came from, and they're all fine ideas, and even the one that we accept kind of at the current time is still an idea or a theory until it's been proven. So what that idea kind of is the Big Bang Theory. The state expects you to kind of understand a little bit about the Big Bang Theory and the origin of matter. So I've put a couple of things up here to just kind of help us out. And I don't know how easy it'll be to read these, but the first one says, everything we know about stars comes from observing their light. We've never sent a spaceship to space, landed on a star, scooped some of that star up, and brought it back to Earth to look at. As of right now, that's absolutely impossible. But we can look at the light that comes through it. And if you remember that lab where we lit basic elements on fire and excited their electrons, they jumped up, the electrons fell back down and gave out light. And we looked through those spectroscopes and we found things that looked a lot like this. And these are called spectral lines. We can use those to do what we call spectral analysis. Spectral analysis is when we analyze the light coming from these stars to figure out what's in the star. It's actually a pretty ingenious way. It's how helium was discovered on the sun before it was ever actually discovered on the Earth. That's why it's called helium, because of Helios, or the sun. All right, so in this simple example, we have star A, and we've looked at its light and passed it through some sort of spectroscope and found that it had these various colors or wavelengths of light. All right, so that's the star we're observing. And then I just put two examples of elements. So this would be something we would know. Hydrogen would have this specific spectral line signature. And if we look at hydrogen versus iron, they're quite different. All right, the way we would use this to know what's in the star is we would look at hydrogen's lines, and if every line in hydrogen was also in star A, and every one, so hydrogen has to be 100% represented in star A. But star A doesn't have to be 100% represented in hydrogen, because star A could have other parts. So we would say that in star A there is hydrogen, because all of these lines are aligned to something up there. Then we would say definitely iron would not be in this star, because iron had many more line signatures or wavelengths that were not represented in the star. So that's kind of how we can learn about stars. Now, what this has to do with where matter comes from is, in order for us to know where stuff came from, we just look at the stars, we look at our own planet, and we've been able to gain some evidence that all matter in the universe is essentially made of the same stuff. Okay, we haven't really looked at stars in years and years and found elements that we didn't know we had here on Earth. All right, so we kind of come up with the idea that if all matter throughout the universe is pretty much the same, then all the matter in the universe probably came from the same place. And that's kind of a piece of evidence for it having its common origin. So we look at the light, we see that it matches things that we know, and we say, hey, it must be that we all came from the same place, like the Big Bang. Now, this little nugget down here, I erased some with my jacket over there, but it says Earth, better come this way, Earth has a higher abundance of heavy elements than most things in the universe. All right, so Earth, we're talking like iron and lower. Earth has a lot of those elements compared to just your average star that's out there in the universe, which most matter is in stars. If we look at a star, it's mostly made out of light elements like hydrogen and helium and a few things, but mostly those two things. And hydrogen would be the most abundant element in the universe. And that's because all these other elements are made when things collide and they fuse together. So like in our sun Our sun is producing energy by taking two hydrogens, slamming them together, making them stick to form hydrogen. Or, sorry, I keep messing that up, to form helium. In that process, energy is released, and we see that as heat and light. Eventually, in larger stars, they take bigger elements, just we'll say sodium and whatever else it feels like colliding with, and those will stick together. They're nuclei, not a chemical reaction, in a nuclear fusion type reaction to create heavier elements. Now, one little nugget of that, since Earth has lots of heavy elements, it actually, all these elements were created in stars. So we literally are just made out of star dust. When stars explode, those elements that are a little bit lighter are then forced together again to make the heavier elements. All right, so a couple of nuggets here. Matter has a common origin in the universe, and we call that the Big Bang. The evidence to support that is that the elements on the planet Earth and the elements that we find in these stars, they are all similar. All right? If they're all similar, we believe they must have a similar origin. All right? And then make sure absolutely you know that planets like Earth have heavier elements than most stars, and that's because Earth came from a star that blew up. That's called a supernova, and that's when elements heavier than iron are made.